Hi, it's Christy at the Bureau, bringing you an update on the extreme geomagnetic storm that affected the planet this weekend, and of course the amazing aurora displays that came with it. Last week, a significant geomagnetic storm event struck Earth, but it started in the Sun. The Sun sends constant heat and light to our Earth, along with other kinds of electromagnetic energy via the solar wind. Now, the Earth's magnetic field protects us from the solar wind. However, every now and then, large and sudden clouds of high-energy plasma are expelled by the Sun, called coronal mass ejections. This is what happened last week, and as a result, electrically charged particles and gas escaped the Sun's gravitational pull and were hurtled towards the Earth, causing a build-up of cosmic dust at the North and South poles. The particles then collided with the gases in our atmosphere to bring a show of lights in our skies at night, the auroras. When the particles bump into oxygen, it results in green and red light, whereas when the particles bump into nitrogen, it makes purple and blue light. Unfortunately, many of the colours of the aurora are not visible to the naked eye, often appearing simply as shades of grey or maybe faint green, as our night vision is most sensitive to green light. Amazingly, this weekend the geomagnetic storm was so intense that colourful auroras were visible to the naked eye in some locations. But the most amazing light shows were seen through the lens of a camera, even the humble smartphone camera. The Bureau observed a number of coronal mass ejections last week, with the most significant occurring on Wednesday and Thursday. These coronal mass ejections arrived in quick succession, causing what became one long-lasting extreme geomagnetic storm event starting on Friday night. We measured geomagnetic storms on what's called the G scale, ranging from G1 minor to G5 extreme. In this case, the storm was rated as a G5 extreme, which is the highest category. G5 storms are relatively rare. The last time we saw one was over 20 years ago, in October 2003. It was these extreme geomagnetic conditions that caused such widespread auroras over the weekend across the planet. Auroras can occur at any time near the poles, but during a geomagnetic storm, they can extend further towards the equator. The stronger the storm, the further away from the poles the auroras can be seen. Scientists combine their measurements of all the different effects of a space weather event on Earth into a number called the Geomagnetic Disturbance Index, or K-index, which has a scale of 1 to 9. An event with a KP index of 3 or 4 means auroras may be visible in Tasmania, while at 5 or 6, Victoria and the south coast of Western Australia are in with a chance. A KP index of 7 or 8 means sightings may extend into New South Wales or even southern Queensland, while a K index of 9 means auroras may be visible as far north as the tropics. You can see here that on Friday night, the planetary K-index rose above 7 shortly after midnight Australian Eastern Standard Time and hovered between 8 and 9 until around 4 AM on Sunday. This is why auroras were visible as far north as northern Queensland and Alice Springs. If this event has ignited a new interest in space weather, then you can visit the Bureau website to stay up to date with our space weather forecasts and activate your very own aurora alert. At this stage, we're at the tail end of this remarkable global aurora event, but the memories of witnessing the dancing lights across the night sky will remain with many people for a long time.